All right. Well, thanks everybody. We welcome you to today's Vaughan Company webinar, Wipes, Designing for the New Sewage Reality. Before we get started, we just want to remind everybody that if you have questions, that bottom box on the right-hand side, that's your Q&A pod. That's where you're going to type them in, and they are going to come back to the back side, and we'll be answering those as we go through. Most of them we'll hold off to the end, but like we were talking about before, if there are questions that we don't get to, we'll work to follow up with you. Also, if you're listening to this on demand and you have questions, then make sure you reach out to the link at the end of the screen, info@chopperpumps.com, or reach out to maybe your local sales team and they'll be able to answer your questions for you. Also, Derek and Eric will have links to their emails as well. Also, if by chance you are hearing an echo on today's webinar, that means you've opened up an extra room or two, and all you have to do is just close out. There's plenty of room in here today. We've got lots of people, but still there's lots of seats, so come in and let's get going. So anyway, all right, let's welcome in today's presenter. That's Derek Vaughan, and Derek is the domestic sales manager for the Vaughan Company, a leading US-based manufacturer of chopper pumps. Over his 15-year career with the company, Derek's worked in a variety of roles, from hands-on pump assembler to business development. Derek, what was your best role at the company?
My best role, the thing that I loved the most, was assembling the pumps when I got the chance to do it. That was a great learning experience, and it was always nice to put your hands on something and get some products out there that you were able to build yourself.
That's great. All right, sir. Well, the floor is yours.
All right, I want to thank everybody for joining us today. This is Vaughan Company's first webinar of what I hope to be a webinar series. And on education and what Vaughan products can do for you as an engineer or you as an end user, the types of costs it'll save, as well as in this presentation talking about wipes that everybody is aware of and the issues that come with wipes and the new sewage, the other new sewage that you'll encounter out there in the world. So what we learned. How wastewater characteristics have changed in the age of wipes and the impact on pump station design, maintenance, and operational resilience. How to assess the true costs of current mitigation practice, capital costs, maintenance costs, impact on downstream operations, and treatment efficiency. How Vaughan Chopper pumps and accessories can improve lift station performance and reliability in this new era of wipes. So to start off, what is the new sewage? What do we see? What's out there? The term has been used as flushable wipes, as you see in quotations there. As we all know, it is non-flushable type material that's getting into the lift stations and causing havoc. Things like baby wipes, cleansing wipes, disinfecting wipes, throwaway mop heads, Swiffers, if you guys have heard that, rags, diapers, elastics, hand towels, Q-tips, feminine products, things that are supposed to go in the garbage but instead make their way down the toilet or down the drain. And to compound this issue, what we have now is we have high efficiency appliances. One of the things that high efficiency appliances do in a lot of cases is use less water. So if you have less water but more solids content in your systems, that's where we're seeing issues. And I'd like to point out one thing that's common between every single one of these is they are non-spherical solids. So what is the result of these flushable or non-flushable wipes? What do we see within our systems? Specifically in pumps, can the solids get in? And if they do, what happens? Many times rags will create a rag ball and they won't be able to even get inside the pump. They'll block suctions, they'll bridge the suction, they'll reduce flow. Long stringy materials will get wrapped on the impeller for wear, due to large consistencies of rags. And once they get into the pump, they can get behind the impeller, they can attack the seal, and you can get some serious seal failures. And after the seal fails, if you're lucky and you get it out, only the seal fails. If not, you could have infiltration into the motor where the whole pump is now gone, or it needs to be completely repaired. So this isn't an issue that is quiet. Everybody hears about it. I'm sure you guys, just in March, there were articles in USA Today, New York Times, the Wall Street Journal urging people, do not flush these things. They wreak havoc on the systems. We monitor social media and are involved in social media, and we are parts of different operator websites or operator pages. And the buzz is the wipes are everywhere. They're clogging systems, they're costing more money. The amp draw due to having regs inside your pump. Um, the cause of having wipes in your system and increased drag on your impeller could be added electricity costs, higher amp draws. Here, like you see here on social media, we have where people ask, please don't flush these. On the left, you'll see this was shared 863 times, and on the right, this was shared 34,000 times. It's an issue that everybody wants to account for and get in front of. So in 2015, this is a map from 2015 from the Maine Water Environmental Association. The cities with significant wipes outreach programs. As you can see here, it's major cities as well as small cities, and since 2015, this has done nothing but grow. According to the International Water Services Flushability Group, states like Washington State, for House Bill 2565, has been passed by both legislative bodies, and it has to do with labeling non-flushable on the packaging of these wipes. Currently, California has a proposal in their House, Minnesota has a proposal in their House, and Washington, D.C. has already passed these labeling practices. So what's the cost? This is a study that was done by the National Association of Clean Water Agencies. The annual cost of wipes in the United States that they put towards this issue is $425 million. Some estimates that are on the web that we've read are even north of that, up to 500 million or even more. And other studies have showed that our friends to the north in Canada, they're seeing approximately $250 million of issues as well. So what makes up these numbers? Where do we get these numbers? Where are the costs coming from? It starts in the collection networks where everything is flushed, through the lift stations, through the headworks, through the treatment plant itself, and out the backside. And if you'll note here on this slide, and if you look through these, there's things like pump maintenance from clogs due to at least part to wipes, pump and grinder combination, pump replacements after failure, extra electricity costs due to wipes clogging pumps, extra disposal costs. There is a cost to each one of these areas when wipes are involved. So if we run through an example and we just take some basic numbers so we can create a baseline, what does it cost at least to work on a station? Now the cost of clogging in a pump station, what we've worked with other groups, they tell us, it takes usually 2 wastewater personnel is needed. You need one person there and one person to watch to make sure that everything goes okay. And if you were to say that, in Washington State, the average salary of a wastewater operator is $31.24 per hour. And you were to say that these guys are very good at what they do. They know this station really well. They may even have tools on site at the lift station, and they can do the unclogging in 2 hours. They can go down, cut all the rags out, cut the wipes out, remove them, put the pump back into service, and that only takes 2 hours. Now, if you do that and you go down, and this is just like a Tuesday, a 9 a.m. on a Tuesday, no overtime, there's no overhead cost figured into this. If 2 guys, and it takes 2 hours, and they unclog a pump once a week, the base of that is $6,500 a year. If they go down and do 2 clogs a week, that'd be almost $13,000 a year. 3, almost $20,000 a year, and it goes up to $45,000. That is low estimate. Now, if you start adding in the cost of possibly bringing in a vac truck or another group or a third person to come in, or overtime is added in, then it just compounds and goes up from there. And what we've noticed in working with people is sometimes this is just a regular job that they do. It's my job on every Friday is to go down and pull the regs out of pump station 27. And so that is an issue. That is not a standard operating practice. So what else is in the new sewage? We've talked about the flushable wipes and all the non-spherical solids. What else are we seeing? Floatables and grease. So what is floatables and grease? Where do we see it? Why is it there? We see it a lot in high traffic areas, restaurant areas, downtown areas, shopping centers, stadiums, anywhere where you're going to be cooking industrial, a lot of industrial cooking is done, or areas of housing where, people do this, where they're cooking their food and they decide, I don't want to take the grease and dump it out. I'm just going to dump it down the drain. Well, that little bit of grease, yeah, maybe that one time isn't too bad, but if everybody in the area is doing it, you'll have an accumulation of grease on the layer. You'll get floatables. And the problem with that is the floatables will become intertwined with rags and wipes. And you'll have what you see here, which this is a station in California. And what we're looking at, picture you're looking through a manhole straight down. This is liquid, this is the water, and this is a floating mat. And as you can see, it almost looks like you can walk on that. Again, the liquid, the floating mat. So what is the result of grease in the collection systems? What does it do? Well, besides clogging a station, we all know it clogs pipes. That's an issue. But you get poor station operation, clogging, costly maintenance. How often do you have to clean that station? How do you clean that station? You can also get blockages. What recently has come up is in cold weather environments, this floating layer will freeze. And when it freezes and the duty pumps pump out, this floating layer then will drop on top of the liquid level, and it can break things. It can rip floats out of the wall. It can knock the pumps off of their base elbows. It can be an extreme issue. So it's a problem in a lot of areas. Also odor. If you leave that there could be an extreme odor issue. So just some round numbers to talk about the cost of cleaning a lift station. I mean, everybody has their costs. We've been told $50,000, $100,000 to clean this station. Now, but what does that mean? Where is that coming from? So when you clean a station, there's some things that you need. The potential for a vac truck is high. Do you want to buy a new one? Between $250,000, $450,000. Do you contract it out? 255, 295 hours for vac truck services. These are all costs that were taken from Washington State. If that's the case, you're going to use a vac truck. You also need a sewer pumper truck, because if you're vacuuming out the waste, you need to put it in the pumper truck and send it back to the site, back to the wastewater treatment plant. What about a bypass pump? Do you need a new unit? What about the cost for that per day? Different rental companies, major rental companies have given us pricing on these things. And for a 6-inch model, you're looking at, in Washington State, about $450 per day. The other things that might not be thought about as you would have to clean a station is, can this station be taken offline or can it not? Is it an extremely important station? So if that's the case, you may need surge tanks, which, the cost just to bring them in could be in freight costs, $500-600 a piece just in freight. And then you start talking contractor fees, connect piping, set up equipment for station clean out. And again, if this is an important station that we're going to experience that cannot be shut down, then you have to do the clean out at night. And then you add overtime pay and the pay of the other workers. It ends up adding up very, very fast. Now, this is the cost of a typical city, 3MGD. This was taken off of a municipal website. This was the winning bid for cleaning lift stations in Burlington, Massachusetts. So Burlington is a town of 25,000 people, approximately 15 stations, and they actually contract with the group. They clean out every 2 weeks. Cleaning events, 780 hours is what they're estimating cleaning to be. The material costs, as you see. the hourly rates. The winning bid for this city was $180,000 per year to clean stations. One thing we haven't talked about is the cost of health and safety. We've talked about the cost of wipes and what they do to pumps and the amp draws that they cause and the grease and the issues, but what is the cost of health and safety? To us, there isn't a cost. You don't want to be there. And what you want to do is, the frequency of cleanouts, the frequencies of unclogging, the frequencies of draining an entire station and dealing with the waste it's unnecessary exposure. So what we're trying to do is, or what we need to do is minimize this unnecessary exposure. I've been places before where you can see in this picture these rag balls and these hypodermic needles. They were calling these porcupine balls as they brought them up from the station because they'd be filled with hypodermic needles. So what can Vaughan do for you? What sort of innovative and reliable solutions to the new sewage do we have? We'll talk a little bit about Vaughan Company. We've been around for 60 years. We've been awarded 30 international and domestic patents for our chopper pumps and mixing equipment. This is what we do. We've been designed for tough waste and tough wastewater, for stringy solids, for these issues. Now, this is a rundown of what we like to call the concept, which are our cutting features, including and discluding, but our Vaughan Flushless mechanical seal. So here at the eye of the shaft, we have what we call the cutter nut. And the cutter nut breaks up the low pressure zone at the eye of the shaft where you can get some rags that will form and ball up. You have our stationary cutter bar with its cutter bar fingers, and the impeller, which has cupped and sharpened blades that rotate against the cutter bar fingers to create a scissor action that chops and then removes the material from the casing. And on the back side of the impeller, we have what's called an upper cutter. Now, this is for mechanical seals to prevent breakdowns of the mechanical seal, to prevent stringy material from binding and wrapping back there. And then we have our Vaughan Flushless mechanical seal, which is our design. Now, we've stacked up the cutting features here so you can see them from front to back, including our back plate. One thing I'd like to point out is the large suction opening, and you can see the spaces in between the blades here. A chopper pump wants to get the material in order to get it out. So we're not trying to have small suction openings. We want the material to get to us. We want to be able to chop it. We want to get it in and get it out. One of the issues with rags is once they get into the pump, if you don't get the rag out that gets into the pump, then another rag may come along and attach to it. And then another rag may come along and attach to it. And then all of a sudden you have a ball of rags that's wrapped inside your impeller. And what Vaughan does is we use all of these cutting features, some patented, and auxiliary cutters in order to get the material in, get it out without binding. And here you can see on our back plate, many of our chopper pump models have what's called external adjusters. So this, sorry about that. Back here you can see these adjusters. These are essentially jacking bolts. And so what this does is this cutter bar is stationary, and as you move these jacking bolts, you can move this entire silver unit closer to the cutter bar for ease of maintenance in order to create that nice cutting feature as the parts will wear over time. And so one of the issues we had talked about is seal failure. And in order to prevent seal failure, Vaughan Company has created a patented back cutter system, including insert cutter, which prevents stringy material from wrapping and binding around the mechanical seal. In many places in here, you have a a cavity in other people's pumps, and that cavity can fill with grease, with sludges, with stringy material, and then cause seal failures. So what do you do once you chop the material away from the backside of the impeller? Well, Vaughan Company, we incorporate pump out vanes. So as those stray stringy materials get cut away from the upper cutter, they are sent along the impeller vanes and forced out. So we don't have those stray solids getting stuck behind the impeller. Again, the job is to get the material in and get it out as fast as possible. Vaughan Company has identified these crucial pinch points, and we've created cutters in those areas to prevent that binding that you will see. The other thing that the chopper pump does is it creates a natural turbulence within the pump. We do very well with grease. We handle it very well, is that it doesn't stick to the inside of our casing like it can for some other pumps because of that natural turbulence. We pump a lot of fats, oils, and grease at wastewater treatment plants because of this reason. So Vaughan Company in the 90s, we went and we decided to start designing and manufacturing our own Vaughan Flushless mechanical seal. The reason is the radial loads caused by chopping were breaking third-party seal faces regularly. So we needed an option that allowed us to have longer life and be able to deal with these stringy, tough solids and the radial loads caused by chopping. So in the 90s, we came up with our Vaughan Flushless mechanical seal. It's been in service for over 20 years now. It's what we recommend in every case. It is a cartridge type, so it's easily removed and easily replaced. It is oil filled. It is in an oil bath. The seal faces can come in silicon carbide or tungsten carbide. They come standard as silicon. The tungsten carbide faces we use in gritty environments where we may run hotter, and it could be a better option for longer seal life. Like I stated before, our design eliminates the stuffing box in cavities behind the impeller. We saw that as a weak point and an issue, and I believe we've solved that. It's easily maintained. As you can see, there is a vent here. So as the pumpage may blow by, which happens naturally in mechanical seals, you'll have some weepage across the seal faces. If you do get anything that collects in here, this release valve will allow it to drip out. And once you notice that, it's easy to go and flush really quick and be able to move on. So since we're talking about mainly lift stations, I wanted to discuss our Vaughan Chopper pump and our submersible Vaughan Chopper pump specifically. We do things a little bit different than other people. We've added a Vaughan mechanical seal to the mix, which is placed inside of our bearing housing. And you'll notice that the motor shaft, we are not using the motor shaft. We're running two shafts. And the reason is, through a bearing housing, the reason is that if you do have a seal failure, it happens. It's going to happen eventually with any pump. If you do have a seal failure, it doesn't go directly into the motor cavity and then fry the motor. We actually, if you do have a mechanical seal failure and you do get intrusion of liquid, milky type substance, or it just drains the seal oil all the way out, we have an oil level monitor relay that can be connected to the panel. This is an early warning sign and an early detection system that helps protect. It's a reliability issue. We want to be reliable. We want to make sure you know if something happens. As you can see here, this is a non-flexible coupling. This is a steel coupling. We've added another thrust bearing down here. These have 100,000 hours of bearing life, L10 bearing life. Every submersible does, every Vaughan pump does. We want these things to work and we want them to last. So what sort of things can Vaughan Company do for you, and what sort of costs can they save by using a chopper pump? This is a case study we did several years ago. This is the Aberdeen Influent lift station. The old pumps that they had in service were clogging. They were clogging on rags. It was happening approximately once a day. It was something that was on a schedule. They knew that they had to go down. They knew they had to unclog it. It was what it was. They called up Vaughan Company. We were able to offer a pedestal pump, a drop-in pedestal replacement. They didn't have any clogs for the rest of that year. So that, with the cost of that, $29,000, they were able to remove the cost of unclogging that lift station. And at this time, they're looking at purchasing a larger pump or sourcing a larger chopper pump to help with more flow. One thing I'd like to point out, Vaughan Company knows that some customers are on budgets. You can't do a full capital project. So how do we mitigate costs in order to help out with these sorts of problems? Vaughan Company does retrofits, and we're adaptable. So in this situation here, we were able to make a custom base which matched the suction and discharge heights, which made piping changes very limited in this situation, so that we were able to reduce costs in order to install the pump. We also can use existing guide rail systems, we're also able to use existing guide rail systems, and we can adapt to those. We can adapt to many of them. Lots of times we end up replacing grinder and non-clog combinations. Grinder and non-clog combination has its place, but there are issues with that. You do have two pieces of equipment, two wearable pieces of equipment, two that you have to maintain, lots of times two panels, and the cost to repair grinders can be very expensive. So we've been able to replace a lot of those to be able to go to one piece of equipment that can do the same thing that two pieces of equipment do. We're also able to meet horsepower of existing pumps. There is a misnomer out there that chopper pumps are not very efficient at all. Now, over the years, we've taken that as a personal quest to make our pumps more efficient. We're up into the ranges of 60, 70, some of them 78% efficient.
And if I could jump in here, Derek, I think a lot of that comes from the other type of chopper pump with external cutting, and this idea that those external cutting features are going to create additional horsepower requirements, additional energy usage, and contribute to parasitic horsepower losses that really with the Vaughan chopper pump you don't necessarily see. And so that's allowed us to really hone in those efficiencies as well.
Mm-hmm. So, solutions to floatables and settling solids. What can we do to counteract the issues that you're seeing on floatable layers and settling solids that happen in tanks? Here on the left, you'll see our submersible pump with recirculation device. This allows for 100% of the flow, the duty flow, if this is the duty pump, to be sent back into the pit to help homogenize and mix. And we have the exact same thing for our vertical wet well if that's something that you would be or somebody would be interested in. Both configurations. And also in the center is our conditioning pump. So to talk a little bit about recirculators and submersible recirculators specifically, a recirculator is essentially a pit cleaning device. Once you throw the valve into recirc mode, what you're doing is you're resuspending solids, you're homogenizing the mixture, and you're pumping out. So how do you clean something? You can't reach in and grab the floating layer. You can't reach out and grab what's settled on the floor. So in order to get that out and clean it, you need to homogenize. You need to mix it together, create a slurry. And then once it's all slurried, you can then flip the valve and pump out. And what we're saying here is this is one piece of engineered equipment that has multiple functions. You can do the pump out, you can do the mixing, you can do the station cleaning, all with one rotating piece of equipment. Here's a picture of some submersible recirculators. As you can see here, we have the ability to run a duplex system, and then you don't have to have recirculators on both pumps. In this situation, we only have it on one, so they can enter recirc mode. These nozzles are adjustable a minimum of 180 degrees horizontally and 45 degrees vertically. We also can run this on an auto valve actuator system where you can be in pump out or recirc mode. The importance of having recircs in the station like this are to prevent mats from forming in the first place. We want to be proactive, not reactive. So how can we prevent these issues from happening altogether? And that's continuing agitation in a station and the in between pump outs. And depending on the station, it depends on how often you have to pump out or how long your recirc mode is. But that's something that we would be able to help decide. So Eric, you want to take over and show everybody how the recirc system works?
So for the next couple, well, it's going to be a couple animations for me, but we're going to work through how you go about adjusting the nozzle and the adjustability and valving that's available here. We've got a little bit of an animation here. I'm going to get my arrow going. So as we work through these, this will kind of show the different operations of the vertical recirculator, and this will be the exact same setup for a submersible recirculator, except you won't have the discharge pipe and motor. You'll just have the different handles and accessories. So move through the first step, and you'll see as we open this valve here, this valve down here will go back and forth as that swings open, and this is how you change between discharge and recirc. Operation mode. So it's just a simple valve on a handle that you can turn, and this is the handle that would be attached to an auto valve actuator for auto valves applications where you want to set this on some sort of timing that where you're recircing for a certain amount of time and then you're switching over to your discharge. Next, we're going to show how you go about changing the direction of the nozzle. And so we've got a little dog ear here that holds it in place and locks it in. And this can be locked. And then when you open it, it frees up this handle to move. And so you can move this back and forth. And this changes the direction of the nozzle down here and allows it to swing. This only shows a limited range so that you're able to follow it. We weren't able to add the video animation in here just because of different connection speeds and how everybody would view this differently. But this will actually swing all the way to 180 degrees. And so that's how you control the back and forth motion.
And there's videos, video links to this that Scott was talking about before the meeting, everyone. So we do have some videos of a recirculator working, and we do have some CFD analysis of
yes. And then
mixing a pit.
For this, for the up and down directions, there's a pin that comes in here to hold it in place, and then this can be raised and lowered to move this up and down. So you can see as this goes up and down, you can see the nozzle goes up and down, and that's got 45 degrees of motion. And then whenever you're done moving the pit, you put the dog ear back in place, and you're ready to go.
Great. Thank you, Eric. So moving on, what else does Vaughan Company offer in order to slurry a pit? Our patented Vaughan conditioning pump is one way to do it. We've had these for approximately 5-6 years in service. We have close to, I think, 75 out there working, and it seems like whenever we get them out there, there's success. So what is a conditioning pump? A conditioning pump is a chopper pump on a stand with a high velocity steel mixing nozzle. And what it does is it's mobile. You can put it in a pit, in one pit, mix it up. Once that pit's mixed up, you can take it to the next pit, mix that pit up for easier clean out. Multiple styles of nozzles for aiming configurations. We have up aimed, we have double nozzles, We also have different nozzle materials. They can come in a mild steel, a stainless steel. They also can come in a polyurethane type material. One thing is we also use oversized bases. And what I mean by oversized bases is this portable stand right here. And as you notice too, that the nozzle is located below what would be the center line of the pump center line of gravity. So as this mixes, there isn't an issue with it tipping over. Also, this is an engineered solution. It's very important to point out that we need to know what the exact problem is that we would be dealing with. Is it what's a floating layer on top? Is it rags and wipes that could be clogging a duty pump that we need to take care of? Is it settling solids? Or is it everything? We have sizing based off of all of it. We have sizing based off of what we need to do to mix a crust on top of a pit. And what are the applications to look for? Lots of times we see them as protection for non-clogged pumps. You end up in an area where it's too expensive to replace the non-clogs. It's too expensive to go in and clean the station all the time. So you can put this pump in there with the chopper in order to just recirculate and mix, homogenize solids, floatables, and grit, get it back into suspension. Allow the pumps that are the duty pumps to be able to pump out and get everything out. A lot of times when these are used, we've been able to eliminate the use of vac trucks completely. They've been able to just go away. And in the another option is that it lengthens the time of cleanouts. You don't have to go in there so often. One great side effect of any recirculator pump that Vaughan puts out on the market is that you're consistently mixing this material back into suspension. And when you do that, it's allowing a constant stream of these solids to go to the wastewater treatment plant. You're not getting a slug of it. You're not getting it vacuumed out and then dropping it right into the headworks. You're getting this constant metering of material in that the screens can take care of as it gets to the screen. We also have control panels for the conditioning pumps. Again, they're like the recirculators. They can run as often as 24 hours a day, 7 days a week, or they can run intermittently. We can run them on floats and timers. We have moisture and thermal relays. We also have an oil monitor relay, and that's optional. For the conditioning pumps, I want to note that it is optional to have the oil level monitor relay because they are mobile. They do move around. And so what we do is we plug the bearing housing and we just say, please do your preventative maintenance. Don't lax on that. So how do you make your conditioning pump mobile? We talked earlier about using one pump in multiple stations. One way to do that is to have multiple panels at multiple stations and using quick disconnects for the cables for each station. That's been worked out well for some customers. Others have been using mobile generators to move their conditioning pump around from station to station for areas that are having issues with the floatables and the wipes. But we also have these sized out as hydraulic submersibles, so they'll have hydraulic motors as well. All of our submersible pumps can be ran off hydraulic motors, but in some areas where power is an issue and you do have a power pack available, it is a way to use these. So to speak about some applications, here's an application where we have a good before and after picture of a debris mat. This debris mat was anywhere between 6 inches and 24 inches, depending on the time of year and the time of day and what was going on. It was a tough place to get a vac truck into. I had to back down a drive, had to close half a road down. It was a production to get it done. And so this is a before and this is an after. The debris mat is dissipated due to the conditioning pump. It's also done a great job of protecting the non-clogged pumps that are the duty pumps in the station. Another thing it can also do is eliminate grit. So when grit settles out, the pump can't reach out and grab it. The duty pump can't. It doesn't have arms. So in order to make that happen, you have to be able, again, to mix everything up, get it homogenized in order for the duty pumps to be able to pump out. So the Otay River Pump Station, this is some cost savings associated with the conditioning pumps. They had a huge floating layer of grease and solids, large deposits of grit as well. They were spending anywhere between $50,000 and $100,000 per year in station cleaning. This includes vac truck costs, the possibility of other things like surge tanks, contractors, everything. At that time, the duty pumps were huge, or they are still, but they were too big and too expensive to replace. So what were we able to do? Vaughan Company was able to offer an 8-inch submersible conditioning pump on a portable stand using 25 horsepower. Since we've put that into service, there have been no clogs and no vac trucks have had to go back to that installation in 5+ years of service. The payback was in under 3 months. Now, what about reliability? We've talked about some things some accessories and how the chopper pump works, but what about reliability? We have hardened cast steel parts to a Rockwell 60C. They come in stainless steel, CD4, MCU. Our pumps come with externally adjustable features for ease of maintenance, so that you don't have to rip the whole pump apart. It all can be done externally. We allow for 100,000 hours of bearing life for every model. We have our own Vaughan mechanical seal. And we also have our oil level monitor system for dangers that could happen for seal failures, early detection systems. Vaughan Company also carries $5 to $7 million of spare parts and inventory. We built 2 new buildings out back in 2016 that totaled 100,000 square foot addition. We're here for the long haul. We're here to stay here. We have expedite options available. We have try and buy programs available, install lists available upon request, and we are made in the USA. Now, what does reliability look like out in the field? This is a case study that we did with Morgan's Point, Texas, and it resulted after Hurricane Harvey. They were having issues with some existing non-clogs, some ragging issues. Sorry, that's not, it should say 2016, not 2016. And they were replaced in 2016 by a Vaughan pump. And in 2017, Hurricane Harvey hits Houston. Totaled 100 inches of rainfall, 72 straight hours. The station with these Vaughan pumps saw 2.5 million gallons of unscreened sewage, and we had 0 clogs. We waited out the storm. So what are the lessons learned? What did we see? What have we talked about? New sewage is attacking our collection systems and wastewater treatment plants. Current non-clog pumps have difficult pumping and handling new sewage that has non-spherical solids. It's a very important point. Maintenance to unclog a pump is costly. The grinder and non-clog, even though there is a place for them, they are 2 wearable pieces of equipment and they're not always necessarily needed. Vac trucks are expensive to rent and purchase, and there is no cost you can put on anything for health and safety of personnel. Vaughan has a solution. Our pump was designed prior to this wipes issue to handle tough, stringy solids. We were designed for this from the beginning. 60 years ago, my great-grandfather invented the chopper pump with hard, tough solids in mind. And that's the way that we've been able to continue throughout this for the last 60 years with these 30 patents that we've received. The recirculation or pit cleaning feature is very important. We want to be able to be proactive, not reactive in these stations. We want to be able to homogenize the mixture and get it out. A single piece of equipment for multiple jobs. This also allows for consistent metering of materials to the plant, helps even loading at the plant. We also are adaptable and we do retrofits to help budgets out. And reliability is the key for health and safety in a work environment. Just to kind of round out some of the cost savings from the slides today, Aberdeen's were $36,500 per year. Otay River was between $50,000 and $100,000 by eliminating vac trucks and the cleanouts. And we have unmatched reliability as seen in the Morgan's Point case study. We ran all the way through Hurricane Harvey without a single clog.
Well done, Derek. Very
Thank you.
nicely timed, right there with plenty of time for Q&A. So let's go ahead and transition through, and there are a lot of great questions in here, and we're going to let Derek and Eric Larson and Stephanie Vaughan walk us through. But before we go get started on that, just remind everybody who hasn't been putting questions in, right in that bottom box next to Derek's face here is where you're going to put your questions. Actually, we'll open up a whole other screen here so that you guys can type in your questions there. But also, Derek, why don't you introduce real quick the files and web resources and pieces that we've got here so that everybody knows what's on the screen.
Okay, so on the bottom you'll see that there's 4 different case studies: the city of Burlington and Washington State, the Otay River that we talked about, the Aberdeen case study that we spoke about, and Morgan's Point case study. There's also some videos that I feel are important to watch, including our Flushable wipes video that highlights our ability to cut these wipes and pass them. We also have our CFD videos of conditioning pumps and recirculating pumps. And then the Holcomb Lift Station research video.
And then we've got a box right there for everybody. If you've got other ideas for webinars, please put them in there, and that'll come back to the team. Q&A box is there on the screen. Also, the links in the presentation at the top should be hot. If not, then you can always go to chopperpumps.com, as well as if you have questions, or if you're listening to this on demand and have questions, just email us at info@chopperpumps.com. I'm gonna break the mold here, Eric and Stephanie. Mike has one more question that I want to make sure that before a lot of people jump away. Are we planning on doing any more webinars on throughout the time? And I'm going to let Stephanie take that, and then Stephanie, from there, I'll let you go ahead and start asking questions.
All right, that sounds great. All right, hi everybody. I'm Stephanie Vaughan. I work in the marketing department here. We will be doing plenty more webinars. The next webinar we have coming up is on May 5th. It will be at 10 a.m. Pacific time. The topic discussed will be Rotomix, process mixing system. Then we do plan to have many more following that, a couple more Rotomix topic ones. And some industry related webinars as well. Again, our folks here answering these questions as I read them are Derek Vaughan, the domestic sales manager for Vaughan Company. We also in the room have Arnie Swenson. He's the Vaughan Company chief engineer, and Eric Larson. He's the Vaughan Company senior product design engineer. All right, first question here from Ted. When designing a new lift station heavy with wipes, 5 horsepower, 1750 RPM hydraulic, should we be looking at 2-vane or 4-vane impeller?
Generally, this is Arnie Swenson. Generally, our rule of thumb is use the fewest number of vanes possible when dealing with solids. This would be a question between our 3F and our 3G impeller. Our 3F has 2 vanes, our 3G has 4. For this application, if the 2-vane impeller can hit the duty point, we recommend using the 2-vane impeller. Next question.
All right, next question from Larry is, and Derek talked about this earlier, but we'll go over it again. Comminutor used ahead of grinder pumps versus using chopper pumps.
Okay, so that's 2 pieces of equipment that need to be maintained. They may break down on different schedules, so if one breaks down, both are out of commission. The Vaughan Chopper pump can handle both those functions. We are very good at it. less stuff to go wrong.
And this is Eric. Yeah, the other thing too is generally you're going to have your chopper pump is going to be fairly similar to a grinder pump or even a non-clog in terms of power usage and efficiency. And so adding a commutator to the front of that or a separate grinder is always going to be additional horsepower that's going to contribute to more power usage.
Great.
Okay, next question from Luke. Can these chopper pumps handle grease?
Yeah, I don't think I've ever had any issues with chopper pumps struggling with grease.
The grease gets in to the volute just fine. The impeller vanes do a good job chopping it. The broken up pieces seem to scour the internal surfaces of the casing, and we don't have buildup on the interior surfaces. We've been doing grease applications for well over 20 years.
Next question from Sean. How small of a horsepower do you offer in submersible applications?
5 horsepower.
Until recently, 5 horse was our smallest. We have been venturing into some 3 horsepower as we gain more and more confidence in some of these lower horsepower applications. We still like to do them case by case, but bring them to us.
Yeah, when we say that we use 5 horsepower, that doesn't mean that the pump is always operating at 5 horsepower. As the pump operates, it's going to operate at its.
Yes, it may only take 1 horsepower hydraulically on some of these small applications. You want to have the torque available from that bigger motor to power through the big chopping events.
Okay, next question is Paul. How often do you have to exercise the recirculation valve?
If this is our optional automatic recirculation valve, we intend for that to operate every cycle. They're based on a timer system, so when the sump fills up, the pump comes on in recirculation mode for a given number of minutes, enough to homogenize that size pit, and then it switches to pump out mode and draws out the entire contents. That way you're not hit with a whole slug of solids trying to enter the pump.
I think it really depends on the pit too. It's something that really, from an owner standpoint or operator standpoint, needs to be kind of dialed in by the facility. And that's a flexibility that we can offer for them to change that timing up and decide what the best runtime is for their size pit and what's coming into it.
Chuck asked the question, what is a typical weight for the conditioning pump?
Our smallest pumps, they're on the order of about 400 pounds, and our biggest ones, 6,000-7,000 pounds. And that would be for like our big 16-inch submersible with a
Yeah, and for a conditioning pump, I think you're generally going to be somewhere between 500 and 1,500 pounds. Any bigger than that, and you're probably not looking at a conditioning pump anymore. You're probably looking at really replacing the duty pump.
Okay, next question was asked by Michael. He asks, what type of oil and metering equipment is used to monitor a seal being compromised? Seal bearing? Does it require an additional cable other than the power cable, or can the wiring be included in the single pump cable?
Yeah. So on the submersible motors, they have thermal and moisture probes built into the motors. They utilize the second control cord, the control cord that's on those submersible motors, and that's monitored in the control panel. The submersible pumps with the Vaughan bearing housing have an optional oil level monitoring system that would consist of a oil hose that's bundled with the power and control cords.
And in that instance, there are times where if it's an issue and you don't want that extra oil hose, We recommend it because, like I said, it's an early detection of a possible seal failure. But you don't have to have that oil hose. If you're going to lift the pump in and out a lot, like a conditioning pump situation, I believe that it isn't an issue to cap that. We'll still warranty it the same. It's just preventative maintenance is very important at that point.
Okay, Bruce asked, how often do the chopper blades need to be sharpened?
That all depends on the application. We use, our standard material is hardened to 60 Rockwell C. If you are pumping floatables, they have a very long wear life because all the grit has settled to the bottom and you're only seeing the soft floatables. If this is a grit and rock application, your wear life will be much shorter.
And just to clarify, the impeller blades, because of the way they're shaped and the way they contact with the cutter bar, they will wear in a way that will keep them self-sharpening. But once you let that, once they wear enough, that clearance between the cutter bar and the impeller will get large enough that you start having issues with potentially binding, and you'll need to adjust those clearances closer, and that's part of regular maintenance. And then once you've run out of wearable area and you've maxed out your adjustment, that's going to be the time when you need to look at replacing parts and those wearable items.
I have a question here, and I'm sorry, I'm not sure how to pronounce the name. Wall. How do you compare grinder submersible pumps, example Flight, to a Vaughan Chopper pump?
So some of the other grinder and chopper pumps, they do not have what we call positive chopping. In other words, some of the material goes through unchopped. On our pumps, everything has to go between the cutter bar opening and get sliced off in even increments as it goes through the pump. Everything gets chopped, nothing skips through. We also do it with let's finish that off. Let's call that one done.
Okay, Mike asks, when using a VFD to track well level for smoother operation in larger pump stations, what is the amount of capacity turn down that can be achieved without affecting reliability for plugging?
The short answer is 75% speed. The long answer involves the system curve and the amount of static head, and you want to make sure that when you do your turn down, you're not pushing the pump over too far left on the curve into the low flow cavitation zone. We can look at that for you case by case if you just give us the data.
It's also very important to note that you would want to use a constant torque VFD when using a chopper pump.
All right, let's take a quick breath here. We're almost at the top of the hour. Derek, Eric, Stephanie, you guys have time for a couple, 2 or 3 more questions?
Yeah, I've got some time for a few more questions, and then any questions we don't get to, we'll definitely contact the person who asked and get an answer to you.
Excellent.
Okay, all right, so I'll ask a few more then.
Mm-hmm.
All right, next question we've got from Mark. What typical size of temporary conditioning pump do you see for small development pump stations, say 6 to 8 diameter wet wells for suspending and homogenizing the liquid and solids for cleaning purposes? What information do you need to size such a temporary pump?
Pit dimensions, inflow rates, high and low liquid levels, but for small 6 to 8 foot diameter tanks, we're probably looking at a 5 horsepower.
Mm-hmm. Yeah, and it's important to note that we do have what we call our conditioning pump inquiry form, so we can send that out, and it has the details we need, so you don't have to guess. It's all on there. We just fill it out to the best of your ability, and we can get you something sized out.
Next question from Victor. When needing to provide a control panel with Vaughan Chopper pumps, What features and accessories are recommended to be included when building a panel for Vaughan Chopper pumps?
So we have some sample schematic available for typical control panels for different models of pumps. We're willing to share those with anybody who needs them. In addition to the normal start-stop level controls, we have motor thermostats, motor moisture, low oil level monitor. We can also build in special features like low current off. We work with multiple control panel manufacturers. We can have control panels custom built for you, or we can share the drawings with your local favorite panel shop and let them build it for you.
Okay, I got last question here from Tammy. What does the Vaughan pump do to the porcupine balls?
It chops into small pieces. We have big inlet openings. The needles, the rags, the hair fiber, it all gets chopped up into small pieces, small enough that it exits the pump discharge flange without plugging, and small enough that it's not going to plug the downstream material. The needles, the metal, that's easy for us to chop. We have other applications where we're chopping way more metal than that.
And I think the big thing there is instead of having to pull it manually out of the pit, it helps move it to where you actually have screens and other systems that can automatically remove that, where it's not getting human contact, where you're not putting operators in harm's way. And I think that's the big key there.
All right.
Absolutely.
Well, let's go ahead and wrap things up. We really appreciate everybody's participation and joining us during this webinar talking about the new sewage reality. Derek, before we go, you want any last words or directions?
I appreciate everybody joining today. Please contact us if you need any more information, and please come back and visit us for our.
Well, thanks everybody. Thanks Derek, Eric, Stephanie, Arnie, everybody who participated. We really appreciate it. If you guys have any other questions that we didn't get to today, or if you're listening to this on demand, just email us at info@chopperpumps.com or contact your local sales rep. And just like Derek was talking about, our next webinar is scheduled 2 weeks from today, May 5th, with It's in the Mix, mixing it up with the Vaughan Rotomix process mixing systems. Learn more and register out there at chopperpumps.com. And with that, we're going to call it good. Thanks, everybody. Thanks again, Vaughan team, and we'll see you all later.